A radio signal has an amplitude inversely proportional to the distance from the transmitter. If the amplitude is 150 millivolt per meter, in part, I think I misspelled milli there in the millivolt, but at a distance of 10 meters, how far away will the signal have fallen to 5% of this value? Okay, some interesting numbers there, but this is a proportions kind of question. I think it's maybe obvious since we're in that topic, and it starts out by talking about inversely proportional. But what does inversely proportional really mean? That's kind of like 1 over. So I'd like to come up with some variables here. I think the radio signal amplitude, I'm just going to use the variable A. It turns out other variables might actually be used for that if we get into the physics of that. But I think for right now, A is going to be intuitive for amplitude. And it's saying is inversely proportional to the distance from the transmitter. So the way I'd like to write that is I'm going to write the proportional to symbol. And inversely means 1 over, like I said. So I'm going to write that as A is proportional to 1 over D. Somebody else could write this as A is proportional to D to the minus 1. That is another option, but unless you really like that, this is fine as well. Although sometimes, I mean, I don't know. Let's do that real quick, because on the key concept slide, we talked about exponents, right? And we had some results. We basically said, like, if you want to set up the proportion, in other words, the relationship sort of as two ratios, you're supposed to include an exponent if there is an exponent. In that sense, this version of this proportion statement might lend itself to that a little bit better. In other words, if I had, say, an A2 and an A1, so in other words, a pair of like A2, D2, A1, D1, etc., as sort of like pairs, the kind of taking at face value, the relationship we had earlier, including the exponent, it would look like this: D2 over D1 to the minus 1. But the thing to recognize is when you apply that exponent to a ratio like this, it's just the reciprocal. So you actually just get D1 over D2, which really deep math fact perhaps is that D1 over D2 is just the same as 1 over the fraction D2 over D1. So we're still doing really just 1 over there. Now, how does this relate to what we have? I think maybe a way to look at this is if I say that A1, I'm going to maybe not use ordered pair notation this time because I don't always want to do that. A1 is equal to that 150 milli. We don't use volts too often in physics 2A, but we're doing it here for a little bit. And millivolts would be like an M in front of that with a capital V per meter. So I could write that 150 millivolts per meter like that. And then that was at a distance. So I think that's telling me that the two kind of paired up values there are this amplitude with this distance of 10 meters. In other words, D1 is equal to 10 meters. And then now let's see, are we given like we've got an A1 and a D1 here I kind of started with. Are we given values for 2? And my answer is like, maybe not, because I'm just given this question of how far away would the signal have fallen to 5% of this value. But I think the way I would interpret that is I would say that means that A2, the second amplitude, is the reduced amplitude. Well, 5% means multiply by 0.05 A1. So if I wanted to, I could do this calculation and, well, let's see, I'm doing the opposite order, I guess, here. I do 150 millivolts per meter multiplied by, for some reason I decided to put it second this time. That's okay though, right? Multiplication is commutative, so I can do that. I could use this to find an A2 and then do everything the way I usually do, but maybe something else I might notice here, another more clever way perhaps, instead of actually doing that calculation, is I could just recognize that this means that 0.05 as a number, which represents that 5%, is really equal to the ratio of A2 over A1. And in that sense, like if I want to use this to answer a question here, since really the thing I don't know, right? Let me, I've got to put this somewhere. Forgot to put it. I often like to identify all my variables at the beginning of a problem or at some point in a problem. And in particular, something that is good to do is to identify the question somewhere in there. In other words, the thing I'm really looking for, the way I've set this up, is D2 is equal to what, right? And then I've got this relationship here based on the inverse proportion. And so in that sense, right, I mean, this is what I'm talking about here. But in terms of numbers, let me see. I've got 0.05 on this side, and I've got a D1 of 10 meters, and again, D2 is the question. So if I kind of don't worry about all this middle stuff, I just have the equation 0.05 is equal to 10 meters divided by D2, which, let me see, a little rusty with my algebra here, but I think if you multiply both sides by D2 and then divide by 0.05, I like to just call that cross multiplication, but I want to make sure I'm doing it correct because I get rusty. Everyone gets rusty with algebra once in a while, right? But I'm running out of space, so I'm just going to do those steps real quickly. If you're not sure, you might check them legitimately to make sure that I did this correctly. But there it is. I get 10 meters divided by 0.05, which now I can put into my calculator, and I think that gives me a nice exact, because this is like 1/20th, right? So it's like times 20, that means 20 times 10 is 200 meters is the answer that I get. I almost ran out of space on this example right there, but there it is. That's the answer.